Assalamualaikum warahmatullahi wabarakatuh. Hi guys, in this video I will show you how to make a connection between microcontroller PIC16F877A and a DC motor. I'm not going to explain in detail about the principle or the architecture of a DC motor because that topic has been covered in other courses. I will show you how to make the connection, what kind of circuit interface should be used for your DC motor. I will also demonstrate some of the programming part as well. And if you need more information about DC motor, you can just Google, for example, this page from rsonline.com. You can find many types of electrical motor. There are DC motor and AC motor. For your information, servo motor and stepper motor also lies under DC motor. Okay, if you browse at the bottom of the page, you can find many information about each type of motor. Or you can also browse on the YouTube. You can find a DC motor, how it works. Okay,
the result is two different kinds of DC motor construction, a shunt and...
So now let's start on the schematic part, and then after that we will do some programming. Okay, first let's find library for DC motor in Proteus. Just type DC motor and we have few options here. But I'm going to choose this one because this one can display the speed of the motor. Okay. Okay, for the introduction, I will connect the DC motor directly to the power supply or battery. Okay, let's find battery. Okay, this one is DC voltage source. Okay, in this simulation, the positive terminal of DC motor is connected to positive terminal of the battery, and negative terminal of the DC motor is connected to negative terminal of a battery. So let's see what happened. First, we need to disable the microcontroller from the simulation because we don't have any program yet. Okay, double click and just exclude from simulation. Let's see what happened. Okay, as you can see, the motor start rotate in clockwise direction. Okay, after some time, the speed of the motor start running at a constant speed. It's about 500 RPM round per minute. Okay, the motor rotate in clockwise direction. Okay, again, see, clockwise direction. Okay, what happen if I inverse the polarity of the battery? Okay, I disconnect, make a new connection. This time, positive terminal of the battery is connected to negative terminal of DC motor, and positive terminal of DC motor connected to negative terminal of the battery. Let's see what happened. The motor rotate in anti-clockwise direction. Okay, but in the end, the speed of the motor is still the same as the previous simulation. Okay, a DC motor cannot be connected to the microcontroller directly. You will damage the microcontroller. The easiest way to control a DC motor is by using a transistor. So let's find a transistor. For example, 2N3905. Okay, this one is PNP. I'm going to choose another one, 3904. Okay, this one is NPN. Alright, let's restructure our schematic diagram. Alright, that's enough. Okay, in this example, the transistor is controlling the DC motor. Let's find resistor. Okay, this transistor. Alright, what happened if I run the simulation? The motor is still off because the transistor is off. Why transistor is off? Because there is no VBE. Okay, let's say I apply a simple voltage to VBE. Alright, so let's see what happened. The motor start to rotate. Okay, very slow, so I will change the value of the transistor 1K. Alright, so in this circuit, to turn on the motor, we need to turn on the transistor. To turn on the transistor, we must apply at least a minimum of 0.7 volt for VBE. Okay, so how do we control the speed of the DC motor? Well, we can use PWM signal to replace the power supply here. Okay, I will stop the simulation and I will remove the power supply. I will replace the power supply with a digital pulse here. Okay, but first we need to configure the PWM. For analog type, select pulse. For pulse high voltage, set it to 5 volt. Pulse width, for first example, I will use 100% duty cycle, and for the frequency, just set it at 100 Hz. So what is PWM? This is PWM. It is a pulse width modulation signal. The signal is supplied to the resistor to control the transistor. So with 100% duty cycle, this one, okay, basically we supply 5 volt to the resistor, to the VBE of the transistor. Therefore, the transistor is always on. Okay, but if I supply with 50% duty cycle, okay, basically we turn on the transistor 50% of the time, and the other 50% we turn it off. So basically the transistor turn on and off with 50% for each on and off. Let's see what happened. This example, the PWM is 100 Hz with 100% duty cycle. So basically the maximum speed of the motor, it might reach 180 RPM. Okay, so now let's stop the simulation and change the pulse width to 20% only. What happened? Okay, the motor rotate but very slow, and the maximum speed of the DC motor is about 15 or 13, something like that. Okay, very slow. Therefore, by controlling the pulse width here, we can control the speed of the motor. Now let's increase the pulse width to 50%. With 100% duty cycle, the speed is about 180. With 20% of duty cycle, the speed is about 15 RPM. And in this example, running right now is 50% duty cycle. The speed is about maybe around 70 or 80. So how do we control this PWM signal from programming? First, let's take a look at the PWM formula. This is PWM signal. Okay, the period is equal to 1 over frequency. The period is the time taken to complete one cycle. Okay, time taken for one complete cycle. So the period is 1 over frequency. Let's say I want to use 100 Hz frequency, so the period is about 10 millisecond. Okay, the duty cycle is the amount of time for the signal to turn on over the total period, and you times 100%. Okay, let's do the programming part. Create new project, PIC Motor, and now we have to connect the PWM. We will replace the PWM signal. Okay, let's say I want to use RB0 here. So in programming, we set trace B. Okay, set port B as output, and then we have infinite loop here. Okay, so now we must turn on the signal for about, let's say I want to produce 50% duty cycle. 50% from 10 millisecond is about 5 millisecond. So what I should do is port B dot F0 equal to 1, turn on the signal, and delay underscore millisecond 5 only, and then we need to turn it off. It's 1, 0 and 5 millisecond. So total is T on and T off is 10 millisecond. This one 10 millisecond. So basically this one is 5 millisecond, and this one is 5 millisecond. We have 50% duty cycle. Okay, build the project. Okay, now we need to load the new hex file. Motor, nope, motor 1 here. Okay, we need to uncheck the exclude from simulation. Okay, let's see what happened. With 50% duty cycle and 100 Hz frequency, the motor start to rotate. And the maximum speed is about 80 RPM. It's getting constant now. Okay, let's stop. Now let's change to 50. This one is 50%. Now let's change it to 80%. So this one 8, this one is 2. So 8 plus 2 is 10 millisecond. Build. This one is 80 millisecond. And the speed is more than 80 RPM. $120 maybe. And now let's change it to 20% only. The motor rotate but very slow, and the maximum speed is about maybe 15 only. So that's how you control the speed of the DC motor using PWM signal and a transistor. Okay. Okay, this circuit is simple and can be used to control the speed of a DC motor for a simple application. Okay, for example, application which require only one direction of motor rotation. However, if your application or your project require both rotation, clockwise and anti-clockwise, this circuit cannot be used anymore. You need to modify the circuit. For example, you can use the H-bridge circuit. This is the H-bridge circuit. Instead of using one transistor to control the DC motor, now we can use 4 transistor combination to perform a H-bridge circuit. Okay, you can refer to website Build Electronic Circuit H-bridge here, so you can read the theory. Basically, what we are going to do is we turn on 2 transistor or a pair of transistor at one time. For example, this one, I turn on the first transistor and fourth transistor, the motor will move forward. And if I turn on third transistor and the second transistor, the motor will move reverse. Okay, now let's modify our schematic diagram here and create an H-bridge circuit. And if you notice, the upper transistor for Q1 and Q3, the transistor is PNP type, and for lower transistor for Q2 and Q4, the transistor is NPN type. Therefore, I'm going to use this schematic for our example. Okay, first I'm going to remove all the components. Okay, for Q1, I will connect to the RB0, and for Q4, I will connect to RB1. For Q3, to the RB2, and for Q4 for RB3. Now the power supply for the H-bridge circuit. and one more is ground. Okay, and let's do the programming part. First, I need to turn off all the transistor. Okay, in this example, I want to rotate the motor clockwise or move forward. So I need to turn on Q1 and Q4. Therefore, the terminal positive, okay, of the motor will be connected to the VCC, and then the terminal negative of the motor will be connected to the ground. So Q1 is connected to RB0 and Q4 is connected to RB1. So this one is for Q1, this one for Q4. Okay, let's say I want to make it 90% of duty cycle. Okay, let's build the project and let's see what happened. Okay, as you can see, the motor start to rotate clockwise and the speed slowly increasing. If you notice here, the red color indicates that this signal line is logic high, turn on, and the Q4 as well. For Q3 and Q2 is turned off. Therefore, the power supply comes from the battery, goes to E, C, and to the positive terminal of the motor. So at this time, the current flow from here through this Q1 to the positive terminal of the motor, and then goes to Q4 and went to ground. Okay, so the maximum speed is about 70 RPM. Now, what happens if I reduce the duty cycle? Let's say I want to make it 30%. Okay, the motor still move to the clockwise direction. But this time, the maximum speed is much lower than the previous example because we changed the duty cycle of the PWM signal. So in this example, the speed of the motor is about 20 only compared to the previous example 70. Okay, now how do I rotate into clockwise direction or reverse? Okay, we need to turn on Q3 and Q2. At the same time, Q1 and Q4 remain off. So Q3 is connected to RB2 and Q2 is connected to RB3. And let's say I want to make it 90% duty cycle. Okay, as you can see, the motor rotate anti-clockwise or reverse direction. The speed should be around 70. And if you notice, at this time only Q2 is turned on and Q3 also turned on. Q1 and Q4 is turned off. Alright, that's it. Okay, Next, I'm going to show you another alternative to control a DC motor, but this time I'm going to use a motor driver L293D. It is a motor driver. So if we take a look at the data sheet of L293D, this is how the pin out. Okay, you can control up to 4 motor actually, and there are 2 sides, side A and side B. Okay, and this is the block diagram in the data sheet. As you can see, there are few method or technique can be used to control a DC motor. Okay, I'm going to show you this part. And this L293D, the supply voltage minimum is 4.5 and up to maximum 7 volt. And for VCC1, VCC2 here, you can use this L293D for DC motor up to 36 volt. So in our example, we just use a DC motor 12 volt. So it should be okay, should be no problem. Okay, this is the first technique and this is the second technique. I'm going to show you this circuit. Why? Because this circuit can be used to control a bidirectional DC motor control. Mean that we can use the L293D motor driver to control the motor to rotate more forward or reverse, clockwise or anti-clockwise. And as you can see here, to turn right the motor, the clockwise, we need to send logic low and high to the input, and to turn it to the left, we just send logic high to input 1A and logic low to input 2A. This one. Okay, and this one 1A and this one is 2A. Okay, if we send both signal low or both high signal, the motor will stop. Or if you disable the enable pin, this one is enable pin. So let's create our schematic diagram. And let's give power supply for the chip and ground as well. As for the power supply for the motor, okay, let's do the programming part. Let's say I want to turn the motor moving forward. So this one is F0, this one is F1. F0 for in 1, RB1 for in 2. So this one is in 2. Okay, 1, 0, and we should enable the enable pin. Enable pin is RB2. So RB2 is 1. Okay, so here, okay, F0, F1, F2, 0, 0, 0. Alright, let's build. And okay, as you can see, the motor moving forward clockwise direction. and the maximum constant speed is about 400 rpm. Okay, let's say I want to reduce the speed. What should I do? Just decrease the duty cycle of the PWM, let's say 30% only. Okay, let's see what happened. The rotation direction is still the same, clockwise, but this time the maximum speed is around 140 rpm. So by reducing the duty cycle of PWM, you can reduce the speed of the motor. Okay, let's say I want to make the motor move in counterclockwise, anti-clockwise direction. So what should I do? Just change the control signal here, 0, 1, and let's see what happened. Okay, the motor move into anti-clockwise direction. Okay guys. Okay, if you ask me which motor control circuit is the best, I would say this one is the best, using L293D. Why? Because it's simple, just using one single chip, L293D. It serves the purpose. It can control a DC motor both direction, clockwise and anti-clockwise. And the cost for this chip also very cheap. If you look at the Lazada or Shopee, you can see the price for this motor driver is about 3 ringgit or 3 ringgit 68 or 1 ringgit, depends on the shop that you choose. Or you might want to try buy motor shield. This one is for Arduino, however it can be used for PIC as well. Okay, and for the exercise, what I want you to do is create a schematic diagram similar to this one. There are 3 switches here, button 2, button 3 and button 4. If I push button 2 here, the motor start to rotate clockwise. Okay, and if I push button 4 here, the motor will slowly stop. And if I push button 3 here, the motor rotate anti-clockwise. Okay, this one is for clockwise, this one is for anti-clockwise. Again, this one for clockwise, this one for anti-clockwise. Okay, this one is for stop. Okay guys, that's all, and good luck. Don't forget to subscribe, like and share. Thank you.